Thank you, Sandro. Good afternoon, everyone. Good afternoon, everyone. It's a pleasure to be here. Although I had to say I haven't brought my sunglasses since I moved to the UK, but yeah, maybe here should have taken them. It's a pleasure to be here in London talking at the GSA event and describing what GaN can do for our sustainable future. So I will start the conversation just introducing a few topics that might be very familiar with you. What is driving the growth of the semiconductor industry? Well, there are four megatrends that are driving it. One is clearly climate change. The second is the digital transformation. The third is the urbanization. And finally, demographics. So these are all megatrends that are really supporting the prediction of having a semiconductor industry of 1 trillion by 2030. Now, behind all these megatrends, there is energy. And energy is predicted to increase, energy consumption in particular, by 40% by 2050. So this is a problem that we had to face. And together with energy consumption, we also have the challenge of electricity consumption that is going to account for 40% of the overall energy consumption that we're talking about. So it's a problem we have to look at. Of course, we have heard several talks looking at several perspectives on how to approach this problem. I would like to take you through a different route and looking how one specific part of the components of the electricity consumption is going to change by using gallium nitride in particular. Now, for the net zero, we have been talking about net zero. Everybody talks about net zero. It's something we have to achieve. And there are several ways we can achieve net zero by 2050, in particular, being below the 1.5 degrees targets that we have. And you can see that there are several technologies, the carbon reduction, the mobility, the industry, agriculture. I would like to focus today on the power section of that chart, which is extremely important. And because of the needs of reducing the power used, there are in particular 3 areas that drive the growth of what are called energy-efficient semiconductor material. Now, in particular, semiconductor material that's used for power electronics, that's the concept I would like to introduce because not many people are familiar with power electronics. And you see here on the left-hand side, or your right-hand side, just the components that CGD brings to the market, which is really a power switch. Now, a power device is a power switch, so it switches as fast as a few kilohertz, so probably you wouldn't be able to see how fast it switches with a naked eye. And 3 are the main areas that are driving the growth of power devices, and in particular, efficient power devices. One is electrification. The second are renewable energies, and the third is the connectivity. And the 3 of them are clearly important for reducing the energy consumption and achieving the net zero targets that we have been talking about. Now, power semiconductor, and that's something else that people don't know too much about it, are really the core of any energy conversion and control system. So we really need to focus on them, on how to make them more efficient, on how to save energy on power conversion circuits. And this is where I would like to take you through why GaN, why there is so much interest in GaN. We have been hearing about compound semiconductor. GaN is a compound semiconductor. We have been talking about gallium nitride specifically. Well, the energy that is transferred from the mains to whatever appliance, whatever applications, has to be converted as much as possible into the power needed by the application. Anything that is dissipated by heat, it's practically lost. So you can see here a comparison of a thermal picture. This is in particular for a low power situation, so 65 watt power supply, so something that would go in the mobile phone, in the power supply of your mobile phone. And you can see how much gallium nitride is cooler than silicon. And that's the main advantage. That's the reason why everybody in the semiconductor industry, in particular in the power electronics, is now looking into gallium nitride. There are advantages that come with the lower heat dissipation. These advantages are, of course, the high energy efficiency, the energy that you can save, but also other key components, the key advantages that will enable technologies such as electric vehicles. And that is the high power density, it's the lower volume, and the fact that the overall system can be much more compact. These are crucial benefits when one thinks about this application in, for example, automotive, or in industrial, in power supplies for data centers. And these are the examples that I would like to give you today. So we've been talking about compound semiconductor. There is another term, wide bandgap material, which is what you see here in the title, is another way to describe compound semiconductor. And these are the materials that will really help opening the new frontier of the mobility. Now, gallium nitride can be used in several applications. You see here a general picture of an automotive, of a car. In general, GaN has been placed as material that can be used in onboard charger. But in fact, what not many people in the industry know is that gallium nitride can be actually used also in inverters, together with silicon carbide, which is currently the dominant semiconductor material for inverter applications. And if one wants to look really, so where is it? Where is it that this material, that these semiconductors are used? Then you can see that they are in the DC-AC conversion parts, in the AC-DC and DC-DC of the onboard charger. So within the complex system of the automotive, GaN can play a huge role. And if combined with the system performance and innovation within the system, one can save not only a lot of energy in the onboard charger and inverter, but also volume and weight, which is crucial for electric vehicles innovation. The other point is renewables. We have been talking about sources of energies, right? My talk really focuses about what do you do once you have energy, once you have sourced it from whatever source it comes from, how can you transfer it in the most efficient way? So renewable energy is another very interesting application for GaN, and that is because, again, there is a conversion from DC to AC, from the solar panel to the grid, and it's essential that anything that is gathered from the power of the sun, it's transferred to the application, to the final appliance. And just to give you an example of where GaN would be used, again, it's in DC-DC, it's in DC-AC, so you can see how it moves from the solar panel all the way to the grid. So GaN can be used in many applications. I gave you the example of the automotive, I gave you the example of the renewable energies, but there is one further example, which I think we should be mentioning more. Simon already has touched on the topic of the energy used by data centers. And this is one of the things I would like to focus today, in particular, calculating the impacts of GaN for data centers. Now, most of the industry, and this is an industry that is booming, right? Because of AI, we all know about that, so I'm not going to focus on that. But most of the industry is focused on this part of the problem. So CPU, GPU, not many people realize how much power in the rack will be needed to deliver the AI revolution. And in fact, we are talking to customers that are claiming that the power of a single rack will be increased by 10 times what it is today. So we're going to go from a 10, 15 kilowatts of need to 100, 150 kilowatts of power. So there is a huge amount of energy that is required to support the AI revolution. And this is where really GaN can help. GaN can help in the AC-DC, in the PFC. There are a lot of applications in the low voltage as well, but the majority of the impact on energy consumption is really in the power supply. And just to give you an example, out of the several components of this rack, the first shelf is usually power supply. And if you had to increase that by 10 times, you would almost have half of it occupied by power supply. So GaN can help, A, in reducing the energy used, and B, in the power density, so increasing the power density, diminishing the space occupied by power supply, and therefore giving more space to the computational electronics that one would like to have on the rack. So we've calculated, we can make a lot of calculations on GaN, but the one of the data center is really one very interesting to me because of everything that is happening in AI and because of everyone talking about just the GPU and CPU and all of that. So we've calculated that if all the data centers were to use GaN, then we could save 23 million or approximately 24 million of CO2 emissions. And then we've done something more because we talk about CO2 emissions, but we can't really touch them, can we? We don't know how much a million is. We don't know how much 24 millions are. So we have calculated the conversion rate in something that is very familiar to us. And in fact, one could consider that that amount of CO2 emissions is equivalent to almost 55 million of barrels of oil consumed. It could be equivalent to 5 million homes' electricity used for 1 year. So it's a huge impact that one could have just by using GaN in data centers. And in these calculations, I haven't even included the impacts on electric vehicles and renewable energies. I would like now to kind of come back to the UK. We have been talking a lot about what has been done in the ecosystem, but also we've heard about what the UK has done in terms of national semiconductor strategy. So first of all, within the ecosystem, there has been a huge amount of investment in semiconductors, at least 25 billion of which in the compound semiconductors, so in silicon carbide, in gallium nitride. And you can see that of that is associated to the growth of the market, 8% to 10%. So the whole world is looking at semiconductor strategies, and the majority of the reasons, so the main reasons behind the semiconductor strategies are the need of an energy-efficient material and resilience within the semiconductor strategy, of course. Now, this is all very important for us. One point I would like to focus on is that within the UK, these are the main priorities of the strategy, but they specifically mentioned compound semiconductor for the reasons I've mentioned. So of course there is photonics within compound semiconductors as well, but gallium nitride is one of the materials, and compound semiconductors are the materials that the UK will invest in to help generate sustainable energy. Now, I just would like to use the last few minutes of the presentation to introduce you Cambridge GaN Devices, but also to give you a hint on what small companies can do within the ecosystem. So first of all, about Cambridge GaN Devices, it's a company that has been running since 2016. We're currently operating from 5 locations, and we are very strong in innovation. So you see our values there, knowledge, innovation, sustainability, and collaboration. So I'm very pleased to hear that the UK has joined the EU Chip Act and will be part of the 1.3 billion euros funding pot for research in semiconductors. That's a great news for the ecosystem. But also about the company, we're growing. We're growing, and we're growing based on the fact that we really want to take GaN into industrial applications and into automotive. We want to take GaN to those high-power applications where really the high energy efficiency of the semiconductor material can make an impact. One more point that I would like to make today. What can we do as a small companies? We have heard about what the other big companies are doing, what Google, what Meta, what Microsoft are doing. These are very big corporations with significant funds behind them. Well, you can imagine that a small and medium enterprise, like the ones that are talking today, they don't have as much funds as Google or Meta. So there is a lot that we can do just simply being positive and acknowledging that there is an issue in the business. And that's what we do at Cambridge GaN Devices. First of all, we believe in enabling the electrification, so using GaN for automotive. We believe that GaN is much more energy efficient than silicon. I showed you the picture of the thermal performance. We believe the GaN process is much more sustainable because you don't have to use the thick substrates like silicon carbide, so the process for GaN is much energy efficient, and at the same time you don't have long diffusion process that is typical of a silicon MOSFET. But at the same time, what can the company do? What can a small company do with the ambition of growing and become a market leader? There is a lot we can do already at this stage. One is, for example, using sustainability as a core value, driving the company, running the company, considering that sustainability is what is really motivating us to grow. We have committed to net zero action through SME Climate Hub Pledge. I don't know how many of you are familiar with this pledge, but it really helps a small company identifying steps to take to achieving the net zero. We have achieved the ISO 14001 accreditation, again, something that a company of 60 people maybe wouldn't have looked at if sustainability wasn't the core value. And the last point, we have an ESG committee, which is formed by several people within the company that are really looking a way of optimizing not only the energy efficiency via the development of the products that we have, but also optimizing the operations within the business, reducing scope 1, scope 2, scope 3 emissions within the business. So this is what really a small company can do together with the ambition of taking GaN into the high energy markets, into the high power markets, and really make the 24 million impacts on CO2 emissions that I've mentioned before, together with the community. And I just would like to conclude my talk with a sentence that I like very much, and I think is very much appropriate to the field of power electronics, which is, with great power comes great responsibilities. I hope that many of you will recognize the sentence. I think it's very pertinent to what you're saying now. And I think we in the power electronics industry in general have a great responsibility. And we have to make sure that we a part of the journey of reducing CO2 emissions, not only with the products, but also in the way we run the business. So thank you very much for your attention. I just would like to conclude here the presentation and hopefully continue the conversation later.